Right. Thank you everyone for attending this session, Modern Java, at Microsoft JDConf 2025. This is actually our agenda for today. And as you can see, we have divided it into 3 parts because I think Java 24 is faster, it is better, and it is definitely easier to use. We got a full agenda, so let's jump right in. One of the big changes to Java was virtual threads. Now, this isn't new to Java 24, which got released last March, but it is still some improvements which have been made. But Java virtual threads, they're really a game changer. So let's dive in what they are. This is the classical threading model where the Java thread class would just be a thin wrapper around an operating system kernel thread. So we've been using this for like 25 years. So we're not saying it is bad. I think it just could be improved, right? Because, you know, threads, you can't, they're quite heavy. So you can't have too many of them. You could have probably a couple of thousand to the max because they are expensive to create. They are expensive memory-wise. So enter virtual threads. So virtual threads, they are managed by the JVM themselves. They're basically just methods that you are calling, and they're extremely lightweight. Calling them is really not very much more expensive than calling a normal method. Now, virtual threads, they have their own thread pool, and they're all tied to a platform thread. Now, when a thread is available to run, it will execute until it comes to a blocking operation. Such a blocking operation could be some kind of IO operation or some synchronized code that is guarded by a synchronized keyword. And then the JVM will actually remove that thread, that virtual thread, from the platform thread and looks at the next one that is ready to run, and it will place that one on. Now, this context switching goes extremely fast and is extremely cheap compared to platform thread switching. So you could easily have like 1 million threads, even if you're on your local development machine, because they're just so lightweight. Now, in Java 24 specifically, some problems with thread pinning have been addressed, where sometimes if you would be in a synchronized block, the thread would be pinned to a platform thread and the platform thread wouldn't be released for the next virtual thread. That has been addressed, and yeah, that's it for virtual threads. Now, how do you create a virtual thread? Well, there's a few ways. There is these methods on the thread class, thread of virtual or thread of platform. Now, these are both factory methods to create either a virtual thread or a platform thread and pass in a runnable. Threads we always used, like, you know, in executor services because they were expensive, so we would batch them. Well, no such thing anymore. You shouldn't actually batch or pull threads anymore. And if you want to change your code and want to use a different executor, instead of the pooling executors, you can now use the new virtual thread per task executor. A second addition from Project Loom next to virtual thread was structured concurrency. Now, we all know structured programming, right? We have the sequence, we have the conditions, and we have repetition. And we had a clear idea how code would flow within this and when, for instance, variables would be in scope or not. Well, structured concurrency is the concurrency alternative to structured programming. You have a parent task or a scope, which we will see in a second. You can fork 1 to n threads that will be executing. Then the parent task will wait for all these threads to execute, and then you can get some kind of a result. Now, if you would look at these in code, it would look something like this. You create a structured task scope, and currently there's actually two patterns. This is the invoke all pattern, which is called shutdown on failure. And I'll explain it. We'll define multiple threads that are going to be executed because we're calling the fork method with the code to execute as a parameter. In this case, we're trying to get the route information, we're trying to load traffic information and load weather information. Then we're doing a scope join saying, well, just wait until all threads have completed. Now, when we get past that point and one of the threads has thrown an exception, the throw if failed method will actually rethrow that exception for you. So the first one that might throw an exception, that one exception is registered by the system and is thrown here. Now, if one of the threads would throw an exception, then the system will automatically shut down the other threads, which eliminates the risk of having dangling threads. And you don't have to do any of that yourself. Once we get past the throw if failed, then we're sure that all threads have completed successfully and we can just retrieve the information. Now here we depend on all threads completing successfully. There's also the invoke any pattern with the shutdown on success. In this example, I'm trying to load weather information from both the Open Weather API and the Rockstars API. And basically, I don't care which one is going to tell me the weather. I just want to know the weather, and the first one that returns wins in this situation. So I don't have to wait for all the threads to complete. If one thread completes with a result, the system will automatically shut down any of the other threads in this situation. Now, one warning, there is a not yet assigned JEP, a Java enhancement proposal for structured concurrency that changes quite some of how the API looks. So look for Java 25 to see how this new API may look. Scoped values. Scoped values were there because they should replace thread locals. Thread locals is actually information you're storing on a per thread basic. Well, that was all real good, but there are some problems when you're suddenly going to do virtual threads, because from 1,000 threads, you're going to go to 1,000,000. So now suddenly you might consume a lot more memory. Threads locals, the idea is you share information between components. For instance, the example where you say, okay, I have this API key, which I get somewhere in the beginning of the application, and I want to pass it all the way to some kind of controller that needs the information. Now you could pass it as a parameter from method to method to method, but that's quite cumbersome. And sometimes you're using an external library in your core stack, and well, you can't change that. So there's no other way than using a thread local, which is basically creating a thread local, assigning it a value, and you can retrieve it anywhere. Now, that also sounds quite good, but there's some problems with thread locals. They're mutable. Mutable state is dangerous because it can lead to race conditions. It can lead to situations where the value is changed, but you're not actually sure where. It is resource intensive, again, because it's mutable, meaning that calling a next method or a next thread, you actually have to copy all the thread local values to pass it on to the next thread. And there's the risk of leaking. That's not only memory leaking because you forget to clean up a variable, but it could also be, take the example of the API key, actually information leaking, not what we want. So scope values came. They exist for a limited time, taking away the risk of leaking information. Only the thread that wrote it can read it. Again, security. They're immutable, so the memory consumption is way better. And they're passed by reference, which makes it, because they're immutable, this is something you can do, and that makes them really, really efficient. Now, how would we use that in code? Here, we have the scope value at the top, where we create two new scope values via a new instance factory method. And then at the bottom, where we actually want to run the code, we're saying, okay, scope secret will get this value, the principal will get this value, and then we're calling the run method, passing in a runnable, or there's also the call method passing in a callable. Once this method has completed, the scoped values will be cleaned up automatically and cannot be accessed anymore. So this is where Java has become faster. Well, where has Java become better? Well, the first part is record pattern matching, or in general, pattern matching. Let's take it a step back. This is the classical switch expression. I say classical, well, switch was always a statement in Java, and since around Java 13 or 14, there's also the switch expression, which is a lightweight, in this case, lightweight expression to use a case. But there's also now switch pattern matching, which looks a bit like this, where we're actually not so much looking at values, but we're looking at the types we're switching over. And depending on the type of information, we are going to do different things. This actually brings us more in the realm of data-oriented programming. So if we look at these two next to each other, on the left, we have the classical switch where we're actually checking for values 0, 10, 100, while on the right, we're checking, is the value passed in, is it a null, or is it an integer, or is it a long or string? So far, and then you're actually acting upon that information. But it doesn't stop there. You can also use pattern matching on your own records. Now, records were added in Java around Java 14, and they're just lightweight data carriers. And here we have a list of frequent flyer objects, which can be apparently either a blue wing, a silver wing, or a royal wing record. And this switch basically says, okay, if the data I'm getting in, if it is of type blue wing, then please send the encouraging email. If it's silver wing, send the nearly there email. If it's a royal wing, send majestic email. So this basically continues leveraging stuff that was added to Java, like sealed classes. Well, with record pattern matching, we even go one step further. So we have this situation where we say, okay, we have a list of members, and they can be a blue wing rec, a silver wing rec, or a royal wing rec. So what does this statement here mean, where we have specified all the variables after the name of the record? Well, if you look at blue wing rec, basically what it means is it checks if the object is of type blue wing rec, and if it is so, it creates 4 local variables: a long for the ID, a name of type string, an email of type string, and an active of type Boolean. And then it will assign the values from bluewingrec.id, that field, to the local variable ID. It does the same thing for the name. The local variable name will get the value of bluewingrec name. Same for email, same for active. So basically, where a constructor takes some variables and constructs a record or class, this is actually a deconstruction method. And those can come in very handy. Again, here's this example of the blue wing rec, silver wing rec, and a royal wing rec. And as you can see, I'm extracting the record into their individual variables, and I can pass these on to the other methods. Also assuring, of course, I could have passed on the blue wing rec at the top situation, but now I'm ensuring I'm only passing on the information that is relevant for the method I'm calling. No more, no less. And that actually brings us to the unnamed pattern and variables, because in the screenshot, you can already see that ID and active, these variables, they're light gray because my IDE said, you defined them, but you're not using them. So would you even want to define them? Well, maybe I don't. So now I can use the unnamed variable and I can substitute these variables with an underscore. As you can see, I can have multiple underscores on one definition, and basically I'm telling the compiler, you know what, I don't care about these variables, just ignore them. Well, you can use that not only in record deconstruction, you can use them in the enhanced for loops. You can use them if you don't care about the return value of a function. You can use them if an exception is thrown, but you're thinking, I'm not going to handle this exception. Maybe not the best situation, but you could. And if you use a try with resources, but not really need access to the resource, you can actually use it like this. Great. That brings us actually to an addition in Java 24, which was primitive patterns. Now, everything we've seen so far, we saw it worked on standard Java data types, and it worked on your own records. It doesn't work yet on your own classes, but it does work now with primitives. So all the primitives in Java, they can also use this pattern matching. And this would be an example, what we see here, of the standard way to use Java, where you say, okay, I got a value and it's case 0, 1, 2, or default. But you can also write code like this. You can say, well, if it's just any kind of int, just say unknown status in this situation. Or we could even take it one step further and say, okay, case 0, case 1, case 2, and then case int. And only when I equals or is greater than 100, I'm going to call the issue gold card. So this is what is called a guarded pattern that can be used anywhere in switch pattern matching, where you can actually put in additional conditions on that case. Great. Well, a nice addition to the Java collection systems is sequenced collections. Now, Java collections have been there since, I think, JDK 1.2, so from the very, very beginning. And we used to have sets, and we used to have queues, and of course, lists and maps. But, you know, they could be a bit cumbersome. Take the example where you want to retrieve the last element of a list. You would have to write something like list get, and then you have to pass in the element number, but you don't know that. So you're going to say list.size -1, hoping that there is at least one element in the list, otherwise it'll blow up in your face. Not the most friendliest API. But that has changed now, because now we have methods like get first to get the first element of a list, or get last. We can insert an element at the top or at the bottom, or we can remove the first element. So, and this is not just for lists, but again, it works for sets, it works for maps, it works for queues. Great addition to the language. Another nice delivery from Project Ember is flexible constructor bodies. Now, we all know the situation. You have a child class, and the first thing a child class needs to do in its constructor is call its parent constructor either with or without parameters. And in the end, every class will inherit from object in Java. So in the end, there is somewhere a call either specified by you or inserted by the compiler to call the object method super to initialize that class. Well, no more. Take this example. This is the statement before super parent, and basically it has a constructor with a parameter. Now, if I want to call this in my own class, basically I'm saying, okay, call the super with a size, as you can see in line 10. But in line 9, there's actually already a call before I'm calling the parent constructor. Now, before this was impossible, the compiler would flag that, no, you can't do that. But that has been changed here. And one of the reasons, one of the things you can do here you can actually get some parameters in, and you can verify if they're actually valid. And if not, just, ignore the whole thing and throw an exception. That could actually save you from doing some expensive operation in your superclass and then finding out that it doesn't really work because some parameter is invalid. There's other use cases for that as well, but I think this would be typically one of the most used use cases. Right, moving on to stream gatherers. So we all know streams. You can construct a stream, there's some input stream, then there's this bundle of intermediate operations, and finally you have a terminal operation that will yield a result. Now, stream sources, the input types could be anything. Collection types, typically there's a stream of factory method. Terminal operations, we had a lot of them. Everyone knows the to list and those things. And then there's intermediate operations. Classical filter and map would be the most used. Well, Gather API actually adds 5 new intermediate operations, but it adds something way more interesting, which is adding your own intermediate operations via an API. This would be a classical way of calling a method with mapping and collecting. And this is how you would use these new intermediate operations. Do you now have the .gather, where you say which method of the gatherers class you would like to use. But as I said, you can also create your own gatherers now. And gatherers consist of 4 parts: an initializer, an integrator, a finisher, and a combiner. Now, of these, only the integrator is required. The initializer will actually, if you have a stateful intermediate operation, it will initialize the state. The integrator will actually process one element from a stream and decide on how to use it. There's a combiner that can combine multiple streams into one, and there's a finisher that can do some operations after all stream elements have been processed. Let's look at a quick example. Here we have an alternative implementation of the map function. This function actually gets a function itself that it will apply to each element in the stream. So I'm defining on line 15 the integrator. There's no state, so I'm specifying the underscore here. Current refers to the current stream element we're processing, and downstream is something where I can actually push the elements in, and then would be passed on to the next method in the stream. So basically, I'm in there now on line 16. I'm just applying the function that was passed in, and then I'm pushing the result downstream, returning true with signals I would like to receive the next element. Now, using this in code, I could say there's a list of Duke and Duchess. I'm calling .gather altmob and applying here, and I'm supplying here as a method the string to uppercase method from string class. And if I would execute this, I would actually get the value Duke and Duchess in capitals. Right. Unnamed class and an instance main methods. This is where Java is getting easier. We all know this. If you would write Java code, you would write public static void main, string array args, and you had to do this. But what does this static mean? Well, for new people new to the language, this might be confusing. So let's leave out the static. So you could write public void main, but public, private, what is all that? We can leave that out too now. And we can even leave out, if we don't use parameters, we can just say void main, which will still be a valid entry point into a Java application, making the Java language easier and more accessible for people new to the language. And talking about that, this is the smallest Java program you can ever write that does something sensible. It's the void main that we saw before, and then we use print line. As you can see, there's no enclosing class because there's basically an unnamed class. You can only have one of those, but it is here. And the print line, it's not a replacement from system out print line. It is from IO print line, where there's also a read line, and a print, and it's automatically imported. So you can execute this code and it will run as expected. Now, if you want to use, for instance, the list class in Java, you have to import it, Java util list at the top of your class. Or you could say, oh, I'm just doing Java util.star, and I'll import every public class from that package. But people new to the language, then they have to know, okay, I want to use the map. So where can I find the map and the date, which date? So maybe sometimes it is easy to import everything in a module. Since Java 9, Java has been modularized into different modules. And if you would take the Java base module, which is like, all the core language features, it will import 55 on-demand package imports. So you could derive your class like this: import module java.base, and you don't have to import the list class specifically. Actually, using this import, you would import so many packages that you can see here. Another thing for newbies to the language is launching multi-file source code program. Since Java 11, you could actually have code and you don't need to compile it first, then pass it to the JVM. You can actually pass it to the JVM, to the Java command, or right away, the Java command will compile it in memory and execute it. So that was really handy. And now we have the options to say, okay, if you have a Java class, class A, and it references class B, then it will compile both. So you now can have multi-file source programs. The final point we're going to touch upon, Markdown documentation comments. Since the beginning of days, we have written out documentation of our Java classes inside our classes using HTML markup. But now we can also use Markdown, which is way more convenient and probably more often used and well known by developers. As you can see here, I can actually have links, I can have lists, I can have underscores, I can have all the things here, and this actually makes your documentation easier to write, and it's more capable of doing things. And that brings us to the end of this presentation. Thank you very much for your attention. I hope you have a great remaining days at the conference, and thanks to our guests from Microsoft for organizing this great conference. Thank you very much.